Hey guys, what's up? I'm back with the next topic from solution, and this is related to the previous lecture, Raoult's Law. So in the previous lecture, I told you about Raoult's Law, and I helped you deriving those three important equations, right? There was one PA equal to PA naught into XA, similarly PB equal to PB naught into XB, and the third one was P total equal to PB naught, multiplied plus XA multiplied by PA naught minus PB naught. This sounds to be a little, difficult to get through you, but what you can do in order to get through this topic, you can check out the very previous lecture, because that's what today's topic is also about. So what today I'm talking about how you can draw the graph of Raoult's law, right? Whatever the equation I just repeated to you, we need to draw a very important graph for that one. So that graph is the today's topic. So indirectly or indirectly I would say today's topic is the graphical representation of Raoult's law for an ideal solution, right? So let's draw that and find out how good or bad this is. But for doing so, I have to take all those 3-4 equations from the Raoult's law. So this is going to be like something from the previous as well. In case you haven't watched it, do watch it before you even watch this very lecture, because this will help you get through quite an easy way. So the first equation I had, the first equation was PA, which is the partial pressure of solution, equal to PA naught into XA, right? The second was PB is equal to PB naught into XB, and the third equation was P total is equal to it's PB naught plus XA, which is the mole fraction of solvent, multiplied by PA naught minus PB naught, right? So this is the third equation. But how this equation came, that is also very important. Suppose the vapor pressure of A is more than vapor pressure of B. What that means? I'm talking about, if out of these two components, if A is more volatile than B, what that means? A will be producing more vapor and hence more vapor pressure than the B. So that is the condition. But in case you change the condition here and you make B more volatile than A, then this equation change and become this fourth one, which is P total is equal to PA naught plus XB multiplied by PB naught minus PA naught. So these are the 4 equations actually, and we did this in quite an easy way, but for that you have to go and check out the previous lecture. Okay, so now we are up to drawing the graph for these equations, right? I'll be using this very first one. This will be used here. Second, this is going to be used, and third, you can use either of them. So I will be using this one. Now for drawing the graph, what you have to do, you need to take things from the mathematics a little bit from there. You remember a linear equation for making a graph, that was y equal to m into x, where y represent to y axis, x represent to x axis, and m is a constant. So just take a look. This PA represent to y, this XA represent to x, and this PA naught represent to m. So what I will do here, to find out the value of y, I will use a different value of XA, right? So what I'm going to do, let XA equal to 0, right? Okay, so if I have XA equal to 0, then what happened? PA will come out, PA will be equal to PA naught. So this is going to be PA equal to PA naught. This is the first value coming up, right? So this is the first value coming up. It's 0, therefore it's 0. Sorry, this is also 0. Okay, now let XA is equal to 1. is equal to 1. What I just did, I imagine, xa equal to 1, but remember you cannot exceed the value more than 1 because mole fraction cannot be beyond 1, right? So 0 and whatever suits to you, you can take two values. I have taken 0 and 1. Now what will happen? PA is equal to, this will come out, PA equal to PA naught. So this is the value coming up. So what we have done now, we have these two value for PA and PA. So these two value, and we'll be making a graph for Raoult's law. So let's concentrate here. This is your first condition which is going to be fulfilled here. So what I'm going, I'm taking this graph right here. This is your y-axis. Doesn't seem to be straight. This is your y-axis and this is your x-axis, right? Your y and x. So on the y-axis, I'll be taking PA. So this is your PA, and there we'll be using XA here. Now what you can do, XA here is going to be 0. However, somewhere there, just imagine it's here, XA is going to be maximum, which is 1. Because these are the two values we have started with. Now, since A is more volatile, so definitely the pressure would be higher than the B. So I'm taking, a point somewhere here, like this one as PA naught, right? So this is the 0 where P equal to, these are two values. So P equal to 0, it's over here, and P equal to PA naught, it's over there. So we are going to get our very first graph, which is this one, right? And okay, so this is the first graph, right, where xa equal to 1 and there the xa equal to 0. Now let me write this, what this represents. This represent PA is equal to PA naught into XA, right? Now let's go for the second equation. Similarly, what we can do, let XB equal to 0, and if we take 0 over here, PB becomes 0. So PB is equal to 0, and if let XB equal to 1, and in that case if XB is 1, this is going to PB equal to PB naught. So we are having PB is equal to PB naught. So these two values are again coming up, and we can draw another graph for the second volatile component. But remember, since the vapor pressure of A is more than B, A is more volatile than B, and therefore, this PB should be somewhere lower than the PA. So what I'm going to do, I'm placing this PB right over here, and what I can do, we can write it like XB equal to 0, XB equal to 0. Okay, so they are 0, but however here it's XB is going to be maximum, which is 1, right? And in that case your graph is going to be something like this, and this represent to PB is equal to PB naught XB. So this is the vapor pressure graph for the second component, which is less volatile than the first one, and this is for the first one. Now we need to move on and find out the graph for the total pressure, and for doing so we again have to use another equation here, and that equation is going to be, okay, so if you remember another equation, y equal to mx plus c, right? Now y represent to P total, M represent to these constants, X represent to XA, and this C represent to PB. Now we will do the similar thing right over here. Let XA equal to 0, because here we have XA. Now if this is 0, this overall becomes 0. In that case P total become PB naught. So P total is equal to PB naught. This is the first value coming up. Now let's take another value for XA. Let XA is equal to 1, and if we are taking 1 over here, just pay attention, if we are taking 1 over here, what will happen? This PB naught will get cancelled, and we will obtain P total equal to PA naught. So we are having P total P total is equal to PA naught. So we have these two values. We can draw the graph for the same. So PA naught is over here, PA naught is over here, and PB naught is over there. This is your PB naught. Sorry, I forgot to write here. This is your PB naught. So what we can do, taking these 2 points, we can draw another graph right over here, and this represent to P total is equal to PA plus PB. You might be surprised, there was some other equation but I have changed over here. It's because PA plus PB when solving, when it is solved, you obtain these equations, right? Where you can check out again from the previous lecture. So this is the graph for the Raoult's law relating the vapor pressure versus the mole fraction. Remember, if it seems to be a little difficult, and you find your concentration is, you are losing your concentration, what you need to do, strike it back, because these are something, not only a bit, I would say difficult, but these are very important, right? So something, topic like this, gives you confidence when you understand. So just to gain those confidence, you have to concentrate on these topic or topic like, this one, because they will help you to overcome your fear, right? So this is something I wanted to help you. This is something I want to do in today's lecture. I hope I made justice with the topic and with you as well. What you can do, if you haven't done or have done it very well, you just let me know through your comment and all. And like I said, in case you need any help, you just feel free to contact me. Contacting me is quite an easy. You can mail me, you can even call me, right? And if you wish to, join me through my, social networking, then you can, check out the links given here or for Facebook and the Instagram. And so thanks for watching. Take care and have a good day.